cover both publishing papers, but also reviewing. As she mentioned, I'm editor-in-chief of Estuarine Coastal Sciences, or one of the 5 editors-in-chief of ECSS. I'm on the editorial board of Marine Pollution Bulletin and linked to various other journals. If you've got questions as we're going through this, can you put them in the chat? Now, I won't be able to see the chat while we're doing this, but if Gemma keeps a note on it, if there's things, Gemma, that it actually would be best to answer the question now rather than wait until later, then just give us a shout, because these things are always better if it's interactive. And also, it's quite likely that some of you listening have already started publishing papers and hopefully refereeing. So you will have your own experiences, and it'd be good to hear about those as well. So we'll see. But we'll start going through how we decide about writing papers, what sort of publishing outlets we have. We'll talk a bit about open access, because this is a main thorny problem at the moment. We'll talk a bit about things like plagiarism, and also get you to thinking about refereeing. Not least because refereeing papers is probably going to be one of the best ways you're going to have of actually reading other people's work in detail. But not only that, reading it in advance of it coming out. You know, the great thing about reviewing is you get to see the work as it's being done. And those of you who are who are doing PhDs at the moment, you'll get to a stage where you will hate looking through new journals, because you'll be scared that someone is going to have published exactly the work that you're doing just before you submit your PhD, and we've all been through this. So we're going to go talk about this publishing cycle. Let's firstly talk about publishing models. And there's nowadays there's a big push on all of us to try and publish things in open access. That is, get the publishing out get our papers out as much as we can. Normally, what we've always done in the past is this, what is called here a traditional publishing model, where our libraries have subscriptions to journals. We can publish, any of us can publish in those journals, and it doesn't cost us because the libraries have already paid for that. So it's the institutions that subscribe to the journals. That still occurs and is still one of the most valuable ways of publishing, especially if you don't individually have the money to publish. But what we're getting pushed towards now is what's called open access publishing, and this is where the person who is publishing the paper pays a fee, pays the journal to publish this sort of thing. So it means that you still own the article, but you're paid in order to get it in a journal. And by now you're probably all getting regular messages from journals encouraging you to send excuse me, encouraging you to send your papers to them. And as long as you pay them, they'll probably publish it. The quality of some of those journals is questionable, so you're going to have to make sure you're only going with reputable journals. But the idea of this, excuse me, the idea of this is that with open access, anybody can get hold of your paper, and even people in organizations that can't afford subscriptions can still get hold of your paper, as opposed to the normal publishing where the paper goes automatically to those who subscribe to the journal. But of course, anybody can write to you and get hold of your paper. What this revolves around is who owns copyright of your paper once it's published. If you give your paper to a traditional journal, that is one who it's subscription based, they eventually own the copyright of your paper. You hand over copyright to them. You have copyright of your paper in those journals right up until it's formatted by that journal. So the last published version, the last Word version that is not typeset in the style of the journal, you've still got the copyright of that, and you can put that on. You can upload it to ResearchGate. You can put it on your local repository. You can give it out to whoever you want. You can put it on your web page. As soon as the journal puts it into their format and you sign over copyright, then it is their it's their property. And by that stage, if it's in a subscription-based journal and you haven't paid an open access fee, then you shouldn't be distributing that published version widely. You can send it out to individual people who write to you, but you shouldn't be uploading that journal to ResearchGate. And by the way, if you did upload that final version to ResearchGate, you'll probably get a letter from ResearchGate saying, we see you're uploading things that you don't have copyright to. Whereas open access, the journal publishes your paper, you've paid for them to publish your paper, and you still have copyright to it. Now within this, there are two sorts of open access. There's what is called gold open access, and that is where you pay the journal to publish your paper. And the fee could be anywhere between $1,500 and $4,000. Some universities, like the universities in the UK, you know, the one that, like the University of Hull that Gemma and I are linked to, they have an arrangement to pay the open access fee for some journals, especially some of the Elsevier journals and that. But with many others, you have to find the grant. You have to find the fee out of your grant. There. So that's gold open access. You have paid the money. The journal publishes it, but you still have control of the version that the journal publishes, and you can do with it whatever you want. The other type of open access is what is called green open access. Green open access is where you are free to use, this is what I said just now, a version of your article, but you haven't paid to have it published, but you can upload the version that you are still in control of. And that's what I said just now, the version which is the one that it's the final version before the journal puts its format on it. And this is what most of us would do. So for example, in our university, if we haven't paid for open access, then we have to upload to the university repository the last version of the paper before it's formatted by the journal. And we can come back to this as well. The next big stumbling block in all this is ethics and plagiarism in publishing. And these are things that I'm sure you've all been told about, but you all have to be wary of. And these are it's an ethical problem, it's a scientific misconduct problem. Firstly, about the ethical misconduct. There are three most common forms of ethical misconduct. One is fabrication. You know, you're making up the research data, and there's some great examples of this over the years. Actually, some very famous studies where people made up the research data. For example, Gregor Mendel's data, which was the first data on genetics, he made up some of the data. If you do the experiments he did, you can't get the ratios of genetic types as perfect as he got it. Now, bit naughty, but he's no longer here to be blamed for that there. Falsification is where you've got some research data, but you're manipulating it in some way. So, for example, you've decided to omit the ones, the data points that you don't like. They don't fit with your idea. The data that you're still giving is true, it's right, but you're misleading people by removing data. And then the third one, this idea of plagiarism, is you're taking someone else's work and you're saying this is what you did, and that's very naughty. And as you know now, with a lot of work that you do, especially when you're producing theses and so on, you have to put it through plagiarism software like Turnitin or something like that. All of these things aside, all of these things are really important. And if you're caught doing any of these, your reputation will just go out of the window. Now, in editing the journal, we've had some really severe cases of these. We've had, especially plagiarism, we've had papers where somebody has taken a paper that's been published, changed the place names in it. Probably we had one where they changed the diagrams from black and white to color, changed the place names from Mexico to somewhere in China, and published it as a new paper. And these are quite difficult to trace, but they can be traced. So plagiarism, stealing someone else's ideas and giving them off your own, is very serious there. And these are the sorts of ethical issues that we're faced with. Things like authorship. Who should be an author of your paper, and whether you're including authors or not. Conflicts of interest. You're reporting something, but you might have an interest in the way it was done. So, for example, you've done a test of various machines, and you have an interest in a company that makes one of the machines, and you've said this machine is as we would say, the best thing since sliced bread, and so on. Duplicate submissions and publishing. When you submit a paper, you have to say this paper is not under review in any other journal. But some people, in order to speed up the process, they would submit the publication to different journals just to try and get published in one of them. And this is and if we find out about this, we immediately reject the paper and probably tell the other journals to reject it as well. So you see, there are and we could spend the whole couple of hours going through all of these cases, but they're all serious in their own way. So we might come back to some of those there. Now, everything that you write probably somewhere goes through plagiarism detection software. Very often Authenticate is used, or Turnitin, or whatever. When we get papers submitted to Estuarine Coastal Shelf Science, we get a comment with them about their level of plagiarism. How much of the paper seems to be copied from somewhere else? And usually this may be, even for any normal paper, this could be up to 20%. Because if you think about it, the references have been published before somewhere. So we'll say, okay, up to 20%, we're not worrying about this. But we do get papers up to 80% or 90% that have got a plagiarism score. Sometimes that may be because the author has produced a report. For example, in these European projects we're doing at the moment, the European project comes out or is underway. We've uploaded a report for the project to the web or to the project software. You write the paper from the report, and it's got a very high level of plagiarism in it. So it's very difficult sometimes it's difficult to detect. these cases where, say, people have stolen other papers and republished them, sometimes that is difficult to detect, especially if they're publishing it in some journal that you've never heard of and is really sort of dodgy journal sort of thing. So we have to be careful about all this. But one of the biggest problem areas for you is what is called self-plagiarism. Now, this is something we all do. We all publish work and then we repeat some of that work in other works. Many of you, if you're doing a thesis and you're writing the thesis according to a set of papers, it's quite likely that the introduction to each of those papers will have the same sort of text in it. You are self-plagiarizing. You've written it once, you've published it once, and now you're publishing it again. Now, many of us think, well, that's probably to be expected. I think I had one PhD student who published 7 papers from her thesis, and all of those papers had to have some of the same introduction and some of the same methods in it, and we had to explain that. But even then, if you are quoting work and it's something you've published in the past, always give a reference for it. When in doubt, give references. I think we would always prefer more references in a paper than fewer references, especially to show that you have got the work that you're mentioning has been seen before somewhere. So you just have to be careful about it, but you are over exaggerating your work sort of thing there. So there are all these minefields in publishing. Things like, as this bit here, materials and methods are usually the biggest problem in this, because there is only so many ways you can describe how you did a technique. And Gemma will know this with a lot of work we're doing. We're publishing about ideas, and there's only a finite number of ways we can describe what those ideas are. So it's quite easy, it comes as plagiarism, but we just have to explain it that way there. So just be careful of this, and I say that the best way is to make sure you give references for your work, and if it is somebody else's words, make sure you demonstrate that. Put it in quotes, or put it in italics, or do some way from it there and that. So this is an ethical problem, and you just have to be aware of all this there. Researchers who plagiarize another author's article, the consequences are that we can get a paper removed. If the paper's just been published electronically in a journal and it's found to be plagiarized, we can get that paper removed. It was rather more difficult when it was printed journals, because then we had to get the journal to issue a rebuttal. They had to put a comment in the written printed in the journal saying this paper should not be cited because it's been stolen from somebody else's there. There. But there. So I say there are problems with this, and if I had more time, I could give you some horror stories on the way people steal work and pass it off on their own. I mean, it seems to be a particular problem in countries, certainly none of the ones that's represented here, but in some countries where a student has to have, say, 2 papers in press before they can submit their thesis, and one of the easiest ways of getting a paper in press is to steal a paper from somebody else, change the names in it, change the places where the work was done, and pass it off as your own. I'm sure none of you would do that, but it is done, sort of thing there. The next thing is when you're submitting a paper, it will, no, it comes to the author, it comes to the editor. We then start looking at it. But before it comes to us, the journal, if it's a good journal, and remember, they're not all good journals, but if it's a good journal, then it will have already carried out some checks. It'll carry out a plagiarism check, and then it will tell me as the editor what level of plagiarism there is. It might, so some of the big publishers like Elsevier, Wiley, Springer, and so on, they might do a quick language check of it and decide that it's not really of the standard for an editor and referees to spend more time on it then. So they would then say, no, go back, rewrite it, get it checked by a native English speaker, and then we'll think about it. The third one of those there is a data report, and there are places for data reports, but a data report is, we did this, here's the numbers and here's the graphs. You've not added anything to it. You've not given any extra interpretation. It really is, frankly, it would be boring to read. And many of us wouldn't get past the editor. The editor would say, no, you've not added anything to make it a paper that somebody else will want to read. Remember what we're all after in all this. We want people to read our papers. We want to have an impact on science, but we, if you're just publishing papers and nobody reads them, they don't get cited, then you have to start thinking, well, what are we doing all this for? So the next part is selecting a journal and then preparing your manuscript. The selecting a journal is quite easy. It's trying to say who is going to read my work and where is the best place to get it read. But just for that, we'll talk about the way what happens with us publishing and how we build a science career. And this idea here was an analysis of Nobel Prize winners. Now, most of us are not going to be Nobel Prize winners. In fact, all of us probably aren't. But it's based on there, and it's came to the conclusion that with in publishing and in science, you have 3 phases in your career. The first phase is getting established, and that's at the stage that most of you are at. And I would say then, you're just starting, get your papers out there, publish where you can, publish when you can, just get your name known. Don't worry about all the metrics in publishing, and we'll talk about those metrics in a minute. But just get your work out there, get started in some way. The second phase is consolidating. By now, you're starting to get known a bit. You can choose your co-authors, you can choose your journals, you can go for a higher impact in your field. Now, what many of us do, and certainly what we do in IX and in the university, we'll go for the top quartile of journals, the top 25% of the journals. We don't have to go for the highest ranking ones, but very often we'll start with the highest rankings and then come down slightly. But we'll go for the top quartile ones. The third phase is what is called capitalizing on your work, and I'm afraid that's the stage that I'm at, where I can spend time synthesizing the information. I can write review articles, I can write chapters, books, and hopefully I can encourage younger people. Now, I've used the word there, proper review articles. We get, in the journal, we get 2 sorts of review articles submitted. We get ones we would call a literature description. Someone has gone through and they've said, Smith says that, oh, I shouldn't use Smith, should I, Gemma? Anyway, Smith said this, blog says this, Green says this, whatever. They're just describing what people have said. they're what we might call sort of a literature description. A true literature review is where you've synthesized information and you've got more information out of it. But again, we might come back to this there. As you publish, you'll get more citations. That's good. It means people are reading your work, and that's what you want. And if you register with Google Scholar, which you all should be doing now once you start publishing, register with Google Scholar and indeed any of the other metrics organizations like Scopus and those things, Web of Science, and you'll get an H index. The H index is a ratio between what you've published and how many citations you've got. And you'll see people's H indexes, indices, and they, as a rule of thumb, your H index should go up by 1 for each productive year of research. So probably starting with your master's or even your PhD, but it should go up. And I've been on panels trying to choose research projects where we have to look at the H index of the PIs now. So within that, so this is what I meant by this sigmoid curve. You're getting established. You're doing all or you're doing most of the work. This is your PhDs there. Consolidating, you're doing much of the work, you're starting to supervise it, but you're building on it, and then capitalizing, summarizing and synthesizing the work. And by that stage, your name probably comes at the ends of papers rather than the beginning, although I try and make sure I get as many papers with my name first as I do at the end. I want to take the lead on papers as well. So this is where we're going there now. Right, choosing the right journal. You want to get your paper read. Now, I'm sure you're all aiming for science or nature papers, but that doesn't necessarily mean that your papers are going to be read by those. It's a bit easier now because everything is electronic, but it may mean that your work just gets hidden. You have to choose one journal. You're not allowed simultaneous submissions. And your supervisor, your colleagues can provide good suggestions. One of the best ways of working out where you should be publishing is have a look at your reference list. You just see, where are you quoting papers from? Because obviously if you're reading in that journal, then if you publish in that journal, then people will read your paper. So doing that. There is a journal finder tool. This is Elsevier's, but all the other journals have them as well. But I say, I don't think I've ever, if I've ever resorted to that. I would usually know which journal we were going to head for, mostly because we would choose one with a fairly good impact factor, but also one where we know people will read our papers. So then just create a short list and look at those. Now look at the journal web page, and it'll tell you these sorts of things. Excuse me. It'll tell you the aim and scope of the paper. It'll tell you the types of paper, who reads it. It'll tell you a list of their recent papers. It'll give you a list of their most highly downloaded papers or their most highly cited paper. It should also tell you their review speed and their publication speed. Now, in Estuarine Coastal Shelf Science, we aim for about probably we probably aim for sort of 6 to 8 weeks publishing from submission to acceptance, but very often that's not possible. The speed depends on the speed of referees, the speed of editor, and especially the speed of the author responding. Usually with most journals now, once the paper has been accepted, then it's published within a couple of weeks because it's all done, or in most cases, it's done electronically. And that, I think recently I had one paper that I handled, which was 6 weeks from being submitted to being published, and that's good going, sort of thing. But very often it's longer than that. Having said that, I was just handling a paper this morning that's been around for a year. It's been a year since it was submitted, and the reason it's taken so long is because nobody wanted to referee it. We took a long time trying lots and lots of referees. Eventually they did respond. We eventually got that, and then the journal has the author has to respond, and so on. So it can take a while. We do get letters from students saying my paper's taking a long time and I'm defending my thesis next week and I need it. I need the paper out soon. And we have to say, well, in that case, you should have submitted it earlier, shouldn't you? If it's their fault for it being so slow. We also get letters from people. They submit a paper one day and then the next day they write saying, what's happening to my paper? Where is it? Why haven't I heard yet? And we say, look, hang on a minute. That means you don't understand the system there. No. As I said, yeah, the reference list and collaborators are usually the best way of finding the right journal. This is Elsevier's. It's slightly out of date because there's a new version of this now, but there are ways of finding the best journal there. The next one is planning the article. Now, there are mainly 3 types of articles. There is the normal normal full article, as it says there, substantial, complete, comprehensive piece of research. This is the article that most of you will be doing now. Your thesis, if you're doing a thesis, that's what your thesis will be composed of. If you're involved in a research project, then that's mostly what these are. Now, each type of paper has a half-life. That is, how long after you've published it will it still be seen? And this talks about the numbers of citations of papers after they came out there. And this is for the life sciences. It's different for things like medical and biomedical and molecular sciences, where these curves aren't as long as that. For example, in medicine, if your paper hasn't been noted and cited within the first few months, it gets lost because the field has moved on. But with many of us, especially in the life sciences, in ecology and in the environment, then our papers are still being cited decades afterwards, thankfully. So these are curves of how many citations you're going to get against the time after publication, and you see there with articles, the green line. So it takes a few months for it to get noticed, and then the papers that are citing it to get into press. So in 2 years it started to be noticed, and then it just tails off fairly slowly. You might have a really good idea and you don't want to wait for a full paper for it. You want to get the idea out there, really just so no one else steals your ideas. And so you produce a short communication, a letter or a note, something that very quickly you can get out. It may only be 2 pages, but it gets the idea out. And I mean, in Marine Pollution Bulletin, we do this with things like editorials, but it gets the idea out there and it allows people to see it. And then you can develop a big idea after that. Excuse me, I should mute myself while I'm busy coughing, but and then the third type of paper, so notes don't last as long because you've got the idea out there, and then what you've done is then you've written a longer article for it. What you'll eventually aim for is a review paper or a good review paper. And those of you doing theses, what I would recommend is you get the first few papers out about the work you've been doing, or the detailed work, And then what you can do is write a review based on those, half dozen papers or whatever. What might even be the last chapter in your thesis, the synthesis. So review papers, they're summaries of recent developments. You can get asked to give these, and as I've said there, we separate the literature review from a literature description. And it's true reviews that get the most citations, because these are the ones that people are going to use to summarize what we know about a field. Now, the last part about this graph is this 2-year band here, this gray area. When a journal calculates its impact factor, it bases it on the citations within a 2-year period. And so it's interested in what citations are coming out for a paper within the 2 years of publication. Now, that's designed, as you see from these curves. If you really wanted to get a better indication of impact factor for reviews, you wouldn't use 2 years, you would use the 5 years, this peak here sort of thing. But this 2-year is based mostly on things like medical and molecular papers, where papers get cited within the first 2 years and then they disappear. Whereas I mentioned in our field, they go on for a long time, and many of us we're still getting citations long after the paper is published. So yeah, we've already talked about that. The next thing is there are lots of metrics of how good you are as a scientist, how good the journal is as a scientist, and so on. All the journals you look at will have an impact factor. That is, the impact factor, how many citations is it getting according to the papers that are being published it. This makes the point that this is slightly out of date now because this has changed, but this was for Estuarine Coastal Shelf Science, impact factor about 2.9, and it was 21st out of 110 in marine and freshwater biology. So it's in the first quartile of that group there. And there's lots of metrics for these. You'll see metrics for this is the 2-year impact factor. There'll be a 5-year impact factor, which is much higher than that, because papers in ECSS get mentioned a lot longer than 2 years. And then also there are all these other types of bibliometric index. And I say, if you get a Google Scholar profile, it will give you a set of your metrics. The projects we're involved in, they will also sooner or later have a Google Scholar page, and we'll get the metrics for those as well. So there are many of these metrics there. Right, the next thing, preparing your manuscript. All of the journals will have guidance on how to prepare your manuscript, what sort of things you should put in, how you should put it in, and so on, and that. It's there on the home page. You've got a guidance for authors. Use it, because if you don't, then all that does is it gives the journal chance to reject your manuscript. Remember, publishing papers is a bit like having grants, submitting grant applications. The people that are evaluating them are looking for ways. We're not looking for ways how to accept papers. We're looking for ways of how to reject them, because there is so many of them. And that. So we're looking for ways of, what is it about this paper that we don't need, we can get rid of. Excuse me. The next bit is the manuscript language. Now, if we work on the basis that, of course, the papers in ECSS and many other journals, or most journals, are in English. That's not because of British dominance in science, it's because of the American dominance in science, and I have to constantly apologizing for English being the working language, but that's the way it is. It's the working language in science, in technology, in commerce, in transport, and so on. What is now global English, and that. We don't look for perfect English. I'm not looking for all of you to use the same sort of English that I would use. It's my native language. In fact, it's my only language. I know bits of other languages, but nowhere near as much as many of you. So we're not looking for perfect English, but we're looking for English that someone can understand. And we have referees that start reading a paper and then reject it immediately. They say, I can't understand it because the English is not written very well. I can't understand what they're talking about it. Therefore, I'm going to reject it. I'm not even going to waste my time reading it. And if you want, and I can send it to Gemma to send around, I've got a set of do's and don'ts in writing English in science there. So just be careful. If you can, get the English checked by a native English speaker. But it's quite likely now that many of you are so familiar in working in English that your English is very good anyway. And also you can use a spelling check and a grammar check just to make sure you're not making any major changes. For example, I was looking at one paper this morning, and the author had talked about they'd used one index and then they'd used many of those, and they used the word many indexes, and I had to say no, the plural of index in that sense is indices. It's only indexes when you've got a lot of the things at the back of a book. But so I had to just point out you're going to have to change this word there. Do the publishers correct the language? No. And editors don't get a chance to correct it either. I used to be able, when I wasn't handling as many papers, I would go through each manuscript and just alter the English slightly. But I probably handle up to 400 papers a year, and I don't have the time to read to correct all of those. So it's your responsibility to do the correction. Who reads your papers? Well, the publishers have got they've got metrics on everything to do with your publications, and they know who is reading what parts of your papers. So 100% of those who see your paper will read the title. Yeah. Many of them, because that's what they were looking for, will read the abstract. Some will take your conclusions. Some are only reading your paper for the methods because they want to compare their work with yours, or they want to know how you did something. Some will take the keywords in meta-analysis, and we've done this. Some have used your data in a meta-analysis. Some are just wanting your references. Some will look at the graphs and so on. I hate to say it, but very few people will read your whole paper. And it's quite likely that with many papers, they've only been read by probably 5 people. No, the 2 referees, the editor, and the first author might be the only ones who ever read the whole paper, and very few will cite it. And the worrying those worrying statistics at the bottom there, of the papers that are published, 40% never get cited again. No. Not even by the author, they don't get cited again. 40% get cited a handful of times, and the remaining 20% may get cited most. So this even happens in the journals I'm involved in. You know, we get a lot of papers that don't get cited. We then have to make the point of, well, why did we publish those papers, or will they be cited in the future? That's at one end of the scale. But we might get some papers that are cited, say, 90 times in a 2-year period. So I know it's a bit of a shock, but just remember that there's a lot of papers that don't get cited. I think these figures probably now might even be out of date because we've got so many journals now and so many dubious journals that keep publishing papers, and they publish papers that will never get seen anywhere. With these statistics here, this is based on good reputable journals, but I say there are so many journals now. Making your you want people to find your papers. You want them to find your work. So put in good keywords, they'll find it. Link your papers with other things. Make sure you've got the right authors. Make sure the images and tables are good. Make sure that people can find your work there. Okay, the next thing, preparing the article. What we're looking for is attractive papers, informative papers, but papers that are going to be very valuable to scientists and workers all over the world. If your paper is only going to be relevant to people within your area, within your very small geographic area, it's not going to get widely taken up. So we want papers that are going to be widely taken up. Nowadays, journals ask for a graphical abstract, something that's going to catch the eye, that they can put on their web pages and is going to catch the eye. It might not appear in the journal, in the paper itself, but it's the sort of thing that sums up the paper. And those things are really good if you're giving presentations or teaching or whatever there. Linking your paper to data repositories. So not only producing your work, but uploading your data somewhere. And this is becoming more and more important now. Giving good highlights. And you'll be asked to give highlights, either 3 highlights or 5 highlights. And in many journals, the good journals, these have a character limit. Usually it's about 85 characters. So you're trying to summarize your papers in those highlights. So you've summarized your paper in a graphical abstract. You've summarized it in the abstract itself. You've summarized it in the highlights. And some people now, some places now are asking for a tweet. Some journals are asking for a tweet, especially medical journals, because they want people to be able to get the information about your paper while they're reading their newspaper over breakfast or something. I don't know if it's still called a tweet. Is it called an X now? Anyway, it is a tweet there. But nowadays you can do more and more. You can put in supplementary material. You can embed a video. One of the things that's being encouraged is embedding a video of you doing your technique. And that is one way of people sort of noticing what you're doing there. So the structure of the research article, which I'm sure you're probably all well aware of this. You know, we've got the main summaries of it, the title, the abstract, the keywords, the visual abstract. These are things that people can search for. The introduction, the methods, results, and discussion, and then the final part. And this is all very simple. Tell people what you're going to tell them it, and then tell them what you've told them, which is no. The introduction is going to say what is the background to why you're doing the work. The method saying this is how I did it. The results saying this is what I found, and the discussion says this is what it means. And then the conclusions are these are the main points of it all. And we'll come back to all of these there. One of the things that's going to catch people's attention is, or the main thing, is the manuscript title. You want something that's catchy, something that's memorable, Not too long. Someone's going to see that and think, oh, that looks interesting. I'll go and read that there. It's got to give the main points. It has to be concise, give the main issues. It shouldn't use technical jargon too much, and you shouldn't really use abbreviations in it, because if you use an abbreviation, if it's not well known, people have to go and look it up. And even by then, they've decided, oh, I can't be bothered looking up. I'll go and look for another paper. Avoid case studies. Because these might then say to the reader, well, this only relates to a certain area. If you're not interested in that area, don't use it, sort of thing. And then, believe it or not, the publishers have information about what improves citations, and having a colon in the title, a question mark in the title, and humor in the title improves citations. It's the thing that gets your paper noticed. There. Yeah, editors and reviewers don't like the titles that are not very good. You know, if the title's not very good, you've already lost part of your audience because they're not going to listen to it. The next thing is the authors. So who is the authorship and who is not the authorship? Now, there is something called the Vancouver Principles, and the Vancouver Principles say that they actually indicate how you should decide who an author is. The main part of the Vancouver Principle is that the authors of it should be able to defend all parts of the paper. They don't have to be able to do everything in the paper, but they should be able to defend it. So, for example, they don't all have to be able to do the statistics, or they don't all have to be able to work the machine, but they should be able to defend why the statistics were used and what the machine did. Normally, the first author is the one who does most of the work, does not only the collection of the information, presentation, interpretation, and so on, puts the paper together. If you work for a laboratory where you do all the work, but the director of the laboratory says they are going to be the first author, then if I were you, I'd change laboratories, because the first, the head of the laboratory shouldn't be the first author unless they did everything in the paper. The other authors, the co-authors, then they've made various contributions. There are problems, these abuses, like ghost authors. Someone was involved in the paper, but you left them out. And it always used to be the case that the laboratory technician was not included in the list of authors, even though they did most of the work. Well, that's not very nice, is it? They did a lot of work. If they did the work, put them in. Make sure they get some benefit from it. The other one is scientific writers and gift authors. It's putting people into the paper who didn't usually do much. And I'm afraid we've all been parts of papers where I know I've been parts of papers where I know some of the authors listed didn't do anything. In fact, I think probably the only thing they did was they checked that their address was right. And I try and avoid these. I try and if you didn't do anything if you don't deserve to be on the paper, then you shouldn't want to be on it. But of course, people want more and more papers. They want a higher H factor. But if you only did a small amount of work, then put the person down as an acknowledgement rather than a co-author. You don't have to have everybody. But we're now getting papers. I'm afraid there's one of my colleagues in Hull that in our medical school that's part of an international research project for health. Every year they collect health statistics, and there are hundreds of authors on these papers. And I doubt whether any of them see the paper before it goes out, but there's hundreds of authors, and I'm not sure any of them should be authors, but they'll probably agree that they'll probably take the view that their data was included in it. So anyway, if you did most of the work, if it's your ideas, you were leading it, even though someone was supervising it, you should be first author. After first author, then there may be a pecking order. It may come under alphabetical order. It may come under the amount of work that people did. Very often the supervisor or the head of the laboratory or the director may be on the paper, but they come last. The person that got the grant may come last if they didn't do a lot of work on it. But I think all of us should be honest about this, and we should say, if you make a good contribution, you should be on a paper. If you didn't make the contribution, just be an acknowledgement. You shouldn't have to do all this. So it's there. Keywords and highlights, these are going to get your paper known. Now, the keywords that you're using shouldn't be the same words in the title, because these indexing journals, they will take the words out your title. So you don't need to put the same words in your keywords. You can use other words in the keywords, which helps people find the paper. They're used by these indexing and abstracting services. Be careful using abbreviations. Only use those that are common or have been used before. And I say the highlights have a number of characters, and we talked about tweets before. The next thing is the abstract. The abstract you should be able to read your abstract on its own without reading the rest of the paper. It should tell you everything about the paper, why you did the work, what you did, what you found, what you mean, what it means there. So it should tell you all of those. It shouldn't have any paragraph breaks in it. It should just be one paragraph. And it will also be the sort of thing that you'll put at the start of your theses. Remember, you're trying to grab the reader. You're trying to make sure this is interesting for them there. Because if the reader reads the abstract and says, "Oh no, paper sounds boring, I'm not going to read any more of it," then you've lost them. So get it as good as you can there. As it says there, many authors write the abstract last. It then really just show what was in the paper there. Right, process of building the article, and this is the way many of us work. I would start off with a set of figures and tables. These are the things that are going to be the meat of the paper. The methods is usually easiest to write. That is what we did. The results are then saying, okay, what do the figures and tables mean? So you start off with your figures and tables. You write onto them. You might print it out, and then you write on them and say, this is what the figures and tables mean. And that there. Or this is what the figures and tables show. Then you say, now what does it mean? And this is the discussion. Now we know what the conclusions are. These are the main points. Now we can go back and finish the introduction. I mean, I'll usually start with some introduction. I'll have made notes. Now, you probably all think straight onto the screen. I do more and more thinking straight onto the screen, but I also very often start off with writing notes on a piece of compressed cellulose paper. I'll make some notes. I might do it while I'm on a train or a flight or somewhere. I'll make the notes, and they'll become the main ideas behind the paper. Then you finish off trying to devise your title, abstract, and keywords. Although I guarantee some of you will submit papers to conferences where you'll submit the abstract way before you've done everything else there. Right. The introduction, I think we've already said this, it's to say what's been done before, what's not been done, and therefore what you are trying to do. So what has been done before? What's the background? What's not been done before, and why we need a paper based on that aspect there. So you're going to go through this, and very often in exactly the same way your thesis should be, it should be these last 3 bullet points. You should give the aim, what is the big idea? And that very often is the title of the paper and your thesis. Give the objectives, might be a set of bullet points. What did you do to reach the aims there? And then, oops, there, okay. And then give the hypotheses or testable questions. Now, the hypotheses, just as the objectives will indicate this is what you did to reach the aims. You know, I did this, I did this, I did this, I did this. The hypotheses should actually give you an idea of what you're going to have to do to analyze the information. The hypotheses will, if you give them properly, they'll tell you what statistics to use. You know, the hypotheses, you know, is there a difference between this and this? Is there a relationship between this and this? They've actually, in doing that, they've told you what statistics to use. For many years, I used to teach statistics to the undergraduates, and trying to get these into them was a challenge there. Write a unique introduction for every article. Do not reuse the introductions. This is what I said before. If you do this, then it's just self-plagiarism there. The methods is the easiest part to write. What you did and how you did it. You have to be careful not to make this too long because, well, firstly, you're going to be stuck for numbers of words. Most papers now are a normal research article, maybe 6,000 to 8,000 words. A review article, maybe 12 to 15,000 words. A short note, maybe 3,000 words. So the methods, you might not have many words to play with, but it may be easy because you can just quote whose were the methods you used before, or you can put the methods into supplementary information, or as it says now, you can actually just upload a video of what you did. So you can make this quite specific, quite succinct there. More and more now, you will have had to have had ethics approval for your work. If you're dealing with animals, any organisms, no, animal, I don't think you have to do it for plants, but for animals, if you're dealing with humans, subjects, you will have had to get ethics approval, either via the project you're working on or usually through your institution. The next bit is the results. What was found by you? So what you're trying to do is give, you know, these are the main data we found, these are the main figures, there are the main tables. Remember, you don't have to repeat in a table what you've given in a figure. If you want, you can put the raw data in supplementary information if you want, but you shouldn't have to give both of those. But you may want to give the data as a table because you want people to see the numbers. Reading off a graph, reading off a figure is rather more difficult to do. So you're going to present your data and you're going to tell people what are the main features of the information. You know, what does it show? What are the are there any outliers? Are there any interesting points? Sometimes it's the data that doesn't fit the pattern that become more important. You know, most of your data fitted a given trend, but actually there was 1 or 2 points that didn't. And you might say, oh, that's really interesting. What about those? Why are those so differently there? So here you're giving the statistical analysis, you're talking about what assumptions you used, and statistics is one of the big areas where papers get pulled up on. Someone will say, oh, I used this particular correlation coefficient, and the referee says, oh yeah, but you can't make the assumptions in that coefficient about your data. You know, you've used a parametric test and you should have used a non-parametric test because you can't make assumptions. So just be careful about that. This last point here about you writing the past tense for what you did and the present tense for what the data show. So you went out and you took some samples, and when you sampled, the area was like that. But the data now show, the present tense, the data now show a particular feature there. So you just have to get these things right there. The discussion is you shouldn't be repeating what you've got in the results. You don't have to say in the discussion, figure 1 says this, figure 2 says this, you can see in table so and so, whatever. That's the results section. What the discussion should be doing is saying what it all means. You should be comparing and contrasting your figures, your information, with what the literature said there. So what you're trying to say is, well, I found this, but that agrees with so-and-so, or that disagrees with another study, and here's the reason why it disagrees with it. And then these questions I've got at the top there that Gemma will have heard many times me use, which is, so what and what if, and then. You know, okay, you've told me something, so what? You give me some data, so what? What does it mean? And the what if is, okay, you've told me that. What if this happens? What is the next stage? And then as a comment that geographers use, and then you've told me something, and then what's the consequence of that? So you have to show that you've done in the discussion, by the discussion, you have to show what you set out to do. You're going to show that you did your objectives and you tested your hypotheses. You should be able to give a critique of your work. Well, we did this, but actually if we did it again, we would do it slightly differently, or this is what we've learned. And those of you writing theses, this is what you'll need in your thesis. You'll need a critique of your work. And then indicate how your research results can be used further. What are the suggestions for further work? But give those suggestions as hypotheses based on what you've done. This is what could be done in future, or this is how someone could use your information there. Whoops, there. Okay, be careful with this. Don't go. Don't extrapolate beyond what your results will show. And all of you should know this. You shouldn't try and go further than your data. Try and avoid emotive expressions. Emotive expressions are, something was a huge change, something was a vast change, something led to a catastrophe. No, you shouldn't be using those terms. Leave those to Greenpeace or various newspapers. You should be very objective in this. You shouldn't be introducing things in the discussion that you haven't introduced already. No, everything should be introduced by the time you come to the discussion. And what you're doing is you're defining all this there. And speculations, well, speculation is not really what you should be doing, but you can speculate, but call it hypothesis generation. If my results show this, then the next stage is this will happen. But give it as a hypothesis for testing next time there. Conclusions, these are, again, you're trying to summarize things. You're trying to tell people what you've already just told them. Very often these are good as bullet points. You shouldn't be giving experimental results here. You shouldn't be giving any references in conclusions. You should just be giving, this is what your work means. Because I say, in many cases, someone will only read your conclusions. They won't read the rest of it there. No. Acknowledgements, these become quite important, and you'll be asked for these when you submit the paper. You might even be asked to give these on a separate page. You have to say who are your advisors were if they're not authors of the papers. You have to say who the funding came from and the grant name and so on. You might want to give acknowledgement to who helped you with some of the work. I mean, we don't usually know proofreaders and typists these days, but you would have done in the past. You might need to acknowledge who gave you any support with your materials, and also you might want to acknowledge the referees. You know, by the time the paper is published, you might want to say, well, 2 anonymous referees helped me with the paper there. And we've talked about the author contribution before, so all those there. References, as I said, I would prefer you to use more references than less, especially to try and avoid plagiarism. If you give a sentence and you haven't given a reference, then it will be assumed it's your sentence until someone says, no, you've stolen that from somebody else's paper. Yeah. So give enough, but not too many. I was just reading one referee's report, and he'd said to the author, well, in your introduction, you've made a sentence, you've given a sentence, and you've used about 4 or 5 references to support that sentence. You probably only need 1 of those references to support it. There. So make sure you've absorbed the material you're referencing. We can spot papers where the author has not read the reference. They've only read the abstract, or might even only read the title. You can spot these because they'll make a mistake in it. Avoid excessive citations. This is a problem many of us have, especially if we're trying to synthesize work, and it's a lot of work we've been doing in the past. Then you end up citing your own papers. But try and keep this down as much as you can. Excessive citations of publications from the same region or institute. This is really, you're trying to show you've read things quite widely. And then conform to the style given in the guide for authors. But this is becoming less important now, in that you can upload a paper with your references in any style, but then when it comes to the final version, you have to use the style of the journal. And there are lots of these like EndNote and Mendeley and all that to help you with this and that. The next bit that's quite important after you've written the paper is the cover letter for it. This might be the first thing that the editor sees about your work. I mean, so when I get submitted a paper, I'll look at the cover letter and then I'll start looking at the paper. And what the cover letter is trying to say to me, my paper is important because it does this. This is why you should think about it, and not reject it very, very quickly. You can include in it the manuscript. It was a former paper, but we've changed it in some way. It was submitted and it was rejected elsewhere, and here's why it was rejected, and this is what we've done about it, and be honest about it there. You will be asked to give suggestions for referees, and we use some of those referees, but also you might be asked for opposing referees, that is, referees that you don't want your paper to go to because there is some conflict. You know, they've always criticized your laboratory's work because they use different techniques and so on. Yeah. And then his final bullet point, remember to change the letter if the paper was submitted elsewhere. And I get this, I get letters to the journal, but they're the same letter that the author used when it submitted it to a different journal. And strangely enough, that helps me reject the paper, because I then think, well, it was rejected by another journal. Let's see if it was changed. And if it wasn't, I'm going to reject it anyway. And if you can't be bothered to change the letter that you're sending to me from what you sent to the others, then it shows that you're not paying attention, and therefore I'm going to reject it. There.
Hi, Mike.
Oh, yes.
Just before we move on, we've got a question in the chat relating back to say self-referencing or choosing a reference. I don't know if you want to come on, Maria, and ask it yourself.
Yeah, that would be good.
Yes, yes. Thank you, Gemma. Yeah, my question is that if you have some references for the same sentence or idea that you are explaining, how do you select one of them?
That's a good point. Go for very often go for the most recent one, or you go for the one that is what we call the seminal work, the most important work. You know, the thing that everyone else has been based on there. So just try and say which one of those. The reason Marie is going for the most recent one is because it is likely that one also contains all the other referees as well. Now you probably know yourself, if you find a paper, the paper gives you it gives you its references, so all the ones that it looked at. But also what you can look up at, what you can look at now is who cited that paper. So you can go back in time and you can go forward in time from when that paper was published there. So yeah, just go for what you consider as the most important. I say it may be the most recent one, or it may be the one that started that idea there. Very often the most recent one would do. So
Okay.
that would be good.
Thank
That's good.
thank you.
Yeah. Okay. So when you submit the paper, you'll be asked to submit to give a list of potential reviewers. No, somewhere between 3 and 6 of them. They're there to help us if we're struggling for reviewers. We have lots of ways of finding reviewers, but this is one of them. We also use your reference list to find reviewers of your papers as well. But what we have to be careful is looking for reviewers that are, is it a good friend of yours? Is it your former supervisor? Is it the place where you used to work? Do you have some link with the reviewer? Look for reviewers that are truly international. So if say you're from one country and you give all the reviewers that are from that country, we will then think, well, they're all a club, they all know each other, and those referees are going to be very, very kind to you. Boy, I don't think it goes for people online here, but very often we get papers, say from China, where all the referees suggested are Chinese, or it's from India and all the referees are from India, and we say no, give international ones. I hate to say it, but that last point on there about fictitious referee email, this does happen. People they suggest referees, and what they've done is they've made up a name, they've registered an email address, they tell us that that person will be a good referee for their paper, and if we send it to that, it goes to the author, who then writes, this is a brilliant paper, you must accept this without any changes. Well, don't do that. You now see what lengths people will go to publish papers. Yeah, and it's terrible there. But I say we will we might use some of those referees if they're well known, if they're international, if we know they're good referees, we might use them. But we also use other ways as well. Okay, let's quickly. I know we're gonna run out of time, so let's talk about the reviewing process. Mostly because you are all now. I'm sure some of you are thinking, "Oh, I haven't published enough. I couldn't possibly review a paper." But don't think like that. You are all probably closer to the literature. I bet many of you are closer to the literature in your field, certainly than I would be. You know, in Gemma's case, she will be much more familiar with modern literature in her field in socio-ecological systems than I would be there. So you're in a good position to referee papers, even if you haven't refereed many before or haven't written many, but at least you should do it. It'll help you there. The peer review is what we need to make sure we get good papers being published. Now, we all have worries because there are some journals now where the refereeing doesn't seem to be very good. And in fact, there's some of these journals where you can pay to publish in, which don't seem to have a refereeing process. They say, well, if you pay us to carry your paper, we'll publish it within 2 weeks. You say, well, you can't possibly get it refereed within 2 weeks. So the peer review is to get as good a papers as we can, and that's what we all want. We want to get rid of the rubbish and get the good papers, get good papers published. And that referees are really important. Now, I work on the basis that for every paper someone publishes, they should referee about 4 or 5 papers. It's getting more and more difficult to get people to referee papers because everyone is so busy, but it's really important work. And that some of our referees will pick up fraud and plagiarism. Paper I mentioned earlier that was it was based on Mexico but had been rewritten to be China, that was detected by a referee. But it was detected by a referee who was refereeing for another journal and who happened to have seen the paper in our journal, the original paper in our journal. So peer review is the control on it there. Yeah. We know everyone is busy, but no, it is part of your scientific career to do this, and the fact you can get rewards for this now as well. Even more if you referee for certain Middle Eastern journals and they say we give you $50 to referee papers, but I don't do many of those. Why do referees review? There's a lot of comments there, and you can read all these things later, but it is your duty as a scientist to referee other people's work. You will learn from it, and I guarantee it may be the only time you read the whole paper. As I said earlier, when people read papers, they usually read them for a reason. I want to see the methods, or I want to see the data. I want to see what literature they used. If you're reviewing a paper, it's one of the few cases where you read the whole thing. It gives you chance to see the new research. It's telling you what's being done before it gets published, and it's going to help you with your ideas as well. So it should be something that you want to do, mostly because well, not mostly, but also you have to remember if you don't review papers, who's going to review your papers? And I'm afraid we know many authors who they want their papers published, but they don't really want to referee other people's papers, which is terrible. No. There are, if you agree to referee papers, then you get certain benefits, and one of them is things like helping you to get into Science Direct. When we look for referees, we have to go through various tools to find the referees, the reviewers. This again is slightly out of date now because we've got a new system, but we are able to search papers and find out who would be a good referee for a paper. So the peer review process is you submit your journal, your article to the journal. There might be another journal screen in there where they just do a quick check, but then it comes to the editor. And this is what I was doing first thing this morning. And that it comes to me, and I screen the paper. Is it something that I think is going to interest the readers? Is it going to interest me? And then we're going to do more with it, or are we going to reject it very early on? And we'll talk about rejection in a minute. But is there some reason why it's not going to go further? And it may be a very good paper, but it's not right for the journal. It's not the right sort of article. It's interesting, but no one else will read it, and so on. Once I've said, yes, it's interesting to the journal, it then goes sent out to between 3 and 6 reviewers. Goes out to reviewers, they review it, and their review keeps coming backwards and forwards to the editors. And then eventually we've said, I've got the reviews, I send the reviews out to the author makes revisions, it comes back to the editor. If I think that the author's made enough changes to it, I'll then either accept it or reject it. If I decide, no, it actually needs to go back to the reviewers, it does this step again, back to the reviewers. And then and this step, back to the reviewers, they make more changes, back to the author, they respond to it, back to the editor, back to reviewers. That may happen, but usually there's no more than a couple of cycles there. If the reviewers have been good the first time and the author has made the revisions necessary, then I can look at that and then I can say, yeah, it's all good. I can accept it. And there's no more revisions required. If all this happens and that the reviewers say the paper, no, it needs to be rejected, or even I say the reviewers are asking for things the author can't make those changes, we reject it. And I say we then will reject it. I'll be kind in rejecting it, but I might say, oh, you've got to make so many changes for it to go somewhere else there and that there. So we screen it to start with. Does it fit the journal scope? No. If it doesn't, it'll get rejected. If the authors aren't creating a paper the way they should do for the journal, then we reject it there. If there's not enough improvement or it can't be improved, we reject it. So you see, it's all these ways where trying to get through. I keep saying to people, producing a paper, it's like running a marathon. It doesn't matter how long it takes to go through this process. If you get to the end, whether it's taken 6 weeks or 18 months, you still get the medal at the end. You still get your paper produced and that. So just be careful on this and that. When you review a paper, then just go through it concisely, systematically. Now, I know we're back to native English speakers. I'm working in my language. I can read your English papers and I can probably take 2 hours to review a paper. And in some cases that might be an hour to read it and an hour to write my notes. But I know some people who English is not their first language and they'll say, oh, it takes me a whole day or it takes me a whole weekend to do it. And sometimes I say to them, well, be careful, because if you spend too much time, you're probably spending more time than the author spent. Yeah, you take as much time as you want. So is the English good enough? Is the title right? Is the abstract okay? Does the methods say what they're doing? Could you read the methodology and repeat their work? What about the figures and tables? Are they the right sort? Are they good enough? Are they clear? Do they contain all the information? I saw one earlier where the figures didn't have the axes explained. And you think, well, that's nonsense then. You know, the reader cannot make anything of your figures, sort of thing there. Get your legends right. So for example, there's one mistake that people make. They want to say how many days, what day number in the year did something happen. So 1 out of 1 out of 365. And they call it Julian days on the axis. Well, a Julian day relates to days since the Roman Emperor Julius Caesar. And today's Julian date is probably something like 76,921. I've just made up that number, but it's that sort of number. It's not days in the year. So just be careful with your figures and so on. Is the discussion okay? Are the conclusions okay? Have all the other things been given there? What you'll then do is you'll then submit your report, and you'll send in your comments to, there'll be two sets of comments. One is comments to the editor, and the others are comments to the author. Now, some people actually just put the same comments in both of those. Many don't even give me any comments as editor. They just give comments to the author, and that's fine. You do get cases where they'll have said to the editor, this paper's rubbish. What are you doing accepting or encouraging papers like this? And then to the author, they'll write things like, they'll be a bit more encouraging. They won't use words like rubbish in it. So, but the things you say to the editor is just between you and the editor. No, but you might want to emphasize things like, you might, I've seen them, it says, this is a brilliant paper. You really ought to publish this as quickly as possible, because it is groundbreaking stuff. So doing this. So you are then making a recommendation to the editor, and you can recommend it's accepted without change. That almost never happens. Accepted with minor revisions or major revisions, or you can recommend the article is rejected, or you can even recommend that it's sent to another journal. One's there. So so say just be careful. This is what you're saying to the editor. You are making a recommendation. It's the editor that makes the decision. So if you find out who the referees are and you don't like them, remember they were only making a recommendation. It's the editor that's that is going to make the decision there. But you need to give the editor enough information in order to do it. I get some papers, again, I was looking at another one this morning where the referee had said, this is fine and could be published. It could be accepted as it is, but then in the next paragraph it said things that could be changed. Well, they shouldn't really been saying that it should be accepted. They're saying it should be it should have minor revisions and so on. The main part is what you say to the author, providing specific comments. It's quite good if you can do it according to line numbers or page numbers, because that helps the author. Comment on the analysis, comments to the author, same as the editor and so on. Use neutral language. Remember, you're not going to be, you're not supposed to be insulting towards them, sort of thing. So be constructive, even if you don't like the paper. Be constructive. No. So I used to give this seminar with a very good friend, Victor de Jong, who sadly is no longer died. He died no longer with us. He died too young a couple of years ago. But Victor put in various review reports. Some of them came from his papers and that there. So as you say, this is what someone said, a less helpful one. Well-written abstract, but there are issues with grammar, peripheral information. So these two red bits contradict that bit there. I felt that in order for me to go further, the text will have to improve substantially. Flow of language, field difficulty, absolutely necessary by so-and-so. So what it's doing is giving various comments on it. No, well-written abstract, issues with grammar. In order for me to go further, they're just saying, oh, I can't be bothered reading this paper anymore. Not there. I'm not happy to complete this unless I'm doing something. So there's more delay and so on. And then another unpleasant, appreciated, absolutely necessary, this paper revised by a person whose native language is English. And it you don't have to say that. You just have to say, get it checked by there. You could do this. You could actually go through and edit the paper. And this is actually like Maria's point earlier when saying you've given all of these references. Do you need them all? And the ones that they've crossed out are because the statements are so obvious you don't actually need you don't need a reference for them. You know, the fact that suspended concentrations change with tidal range, river discharge, and flocculation. Well, we know all that. This is obvious. It's like saying plants need light to grow. There. So you've edited it. Now that will help the author, but just be careful there. And then you get things like this. The referee obviously didn't like this. Again, this is Victor de Jong's paper. They obviously didn't like this and decided there's whole paragraphs they could get rid of. One's there and that there. This was the same manuscript by a different referee. Interesting paper. Urge the authors to persevere with it. Useful contribution. It's being more encouraging. It's still saying things are wrong with it, but it's being more encouraging of this there. So there. So that second one is saying, before publication can proceed, this is what I must insist, but this is what I think needs to be done to it in there. And they're saying, do this, do this, do this, do this, do this. The editor then, when the paper then goes back to the author, then it comes back to the editor. The editor can actually go through these numbers here and say, yes, they did that. 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 Okay, no problem. I can now accept the paper because they've done everything the referee was asking for, and that's what we're after this and that. There. This is there are different ways of saying these things, but there. Yeah, let's get rid of that. A main point is that when you get asked to referee a paper, it is a confidential document. You shouldn't then pass it round. You shouldn't then use the data in it in your papers. You shouldn't really sort of be free with it. If you decide that you really want to ask somebody, especially say your supervisor or your co-worker about it, then do so. But mention this to the editor. Said, I discussed this with one of my colleagues because they have a better knowledge of, I know, the technique or something. But you've told them after it and that. And also, say, it must be destroyed after the final decision for the editor. I mean, I'm sure I because I don't clear out the folders on my data storage, then I probably keep the papers, but I don't go back to them, and you shouldn't go back to them. I say once you've refereed it, you know, you're sending your comments to the editor, and then it's nothing more to do with you, unless of course the author then revises it and the editor decides that the referees should see it again, which often happens. So you might get it back. Then you might want to say, well, what did I say last time, and what am I saying about it now? So anyway, it is a confidential document. You have to behave honourably in this. Don't review manuscripts that are out of your area, because you know you'll be trying to convince someone you know something about it. Make sure you can do the review on time, and once you start reviewing for a journal, then the publishers keep all the indicators about you. If any of you've reviewed for, say, Estuarine Coastal Shelf Science, I can go on your record and I can see how many papers you reviewed. I could see how long you took. I could see whether you accepted them or asked for revisions or rejected them. I could see all of this, anything about it and that. So I say, be honest about this. You know, you are giving critical assessment, but you're there to try and help the author, which is quite important there. Yes, this bit at the bottom there. And eventually, if we get people who've refereed enough papers, we think they would be really good as an associate editor. And we bring them into the journal. We bring them in as associate editors. which it doesn't pay them, but it does give them various benefits like access to journals and various other things there. So and you get asked to be an associate editor, and then and the associate editor doesn't referee the papers, they handle them. That is, they send them out for refereeing. So actually, if you're an associate editor, you might save work. And then eventually, when journals are looking for editors, and the editors may be being paid a small amount to do being editors, they look for who are good associate editors. And now we get people writing to us saying, I would like to be a referee, or if you're looking for an associate editor in this particular field, this is what I work on. Sometimes the papers, or no, quite often the papers come to us and we can reject them without sending them for review. And this is the initial submissions of this. And it depends on various journals. Journals have anywhere between the 30 and 60% rejection rate, what's called a desk rejection rate. So they've not even gone out to referees. In our case, that will be because we think the paper is just not very good, or it's not been written very well, or whether we've just seen it and we realize that the authors are trying to get a second paper out of data that's already been published, or we've been told that the paper's been submitted elsewhere, then it really goes. But in many cases, certainly for journals like Estuarine Coastal Sciences, Marine Pollution Bulletin, Journal of Experimental Marine Biology and Ecology, all of these, if the paper is a very much geographical study, somebody went and they measured, I know, the seabed benthos or the benthos in one area, and here's the results from that, then we'll reject it. But what we'll do is we'll say, send it to, there's a journal called Regional Studies in Marine Science, send it to them, because we don't have the space to take every paper we're submitted, sort of thing. So the editor goes through all this and then is looking, should I send it out to review, or should I reject it there and then? So it goes out to review. You've reviewed it, you've sent your comments in, you've sent them back to the editor. The editor then sends them back to the author, and then the author hopefully makes all the changes, and then the editor can consider it. When you're making the changes to your paper after it's been refereed, when you send it back to the editor, send back a document where you've responded to all the points on it. I mean, even if you disagree with the referee, just say this. And what makes it easier for the editor is where you give a table of, if you give a table of all the referees' comments, and then all the ways you've addressed those, in line 25 to 30, we've added in this paragraph. At page so-and-so, we've decided to remove this bit because the referee didn't want it there, and then we've changed this. Yeah. You can disagree with the referees as long as you say why. For example, the referee might say, you didn't mention this, this, and this in the paper. You can say, yeah, but that's not what our paper was about. If we'd have written that in it, it would have been a different paper. And that's what we might do next time. But actually, our paper is about this. As long as you're honest, the editor say, yes, yeah, I agree with you. I think that's fine there. So you can do all these. You can say how you've changed the paper, how it's improved, and so on. Some journals ask for a track changes version. We don't, but some people will give it. But we need to know how they've changed it. Don't send the paper back with a one line that says, I have done everything the referee has asked me to, because that doesn't help the editor at all. The editor can't see all that there. Then finally, the editor makes a decision. It's trying to say, So should I accept this paper or should I reject it? Very often we get situations like this. We've got 4 reviews. As it says, it's not a democracy. One of them has said reject. Others said it was minor revisions. We looked at these comments here and realized the reject was much more important than all the good points in it. And then we'll say, okay, sorry, we have to reject it. Or what we really have to do is, or what we may do is say, a referee suggests to reject it, but actually we want you to revise it, but be careful because you've got to really make a strong attempt to tackle all of these changes. And we might send it back to this referee that rejected it anyway. There. So you might be asked for minor revision, major revision, changing things. Most papers, if they go to referees, very often they get published sooner or later because the referees, some might reject it, but most will say, well, you could actually improve it by doing this, this, and this, and that's most important thing there. Rejection, it's not the end of the world. Everyone has papers rejected. Now, Gemma says how many papers I've published in my career, and I've had papers rejected, and I've had comments from referees that I disliked, but I have to take them. And we've all got papers that were rejected and we didn't do anything else with them. We've had papers that we couldn't answer the referee's comments, and so they didn't go any further. And then we all promise ourselves that we'll rewrite those papers. When we retire, we'll rewrite those papers, and of course we never did. But many cases we revise the paper, submit it to another journal, or even rewrite the paper completely and send it back to the same journal. But you have to say this is a rewritten paper. It's not an amended paper. It's not minor corrections. We have rewritten the paper and redone the analysis probably. So rejection, we all have papers rejected, but don't worry about it. If it's a good idea, then you'll get the paper accepted sooner or later. Okay, so this just sums up. 2 reviewers at least, good if we can get 3. Sometimes we have to rely on 1 reviewer because we've sent it out to so many reviewers and nobody wants to review the paper that we have to go with that. But usually 2 reviewers. If 2 reviewers agree, then that's fine. If 2 reviewers disagree, then we need a 3rd one, or we send it to the editorial board for checking. Yeah. So we make sure we've got a good balance there. There's usually a time limit, 2 to 4 weeks. Some journals like PLOS One, they give you about 10 days, which is usually too short for most of us. I'm not sat there waiting for papers to referee, and so if they say, can you review it by next week, I'll say no, I can't. I haven't got time there. Right. Articles revised. The editor decides that things have been addressed, and then the reviewer's report helps to make a decision. I say things that hold up the whole publication processes are usually the reviewers being slow. And one thing that makes it worse is if a reviewer agrees to review it and doesn't deliver, that slows the process down. If they just say no, they can't, then we know where we are. And I get to the stage where I might have asked 20 referees and they've all said no, they can't review it. I then start worrying, what is it about this topic that they don't like? Or is it they don't like the author? The author has just annoyed all of them so much they're not going to review their papers. And this happens, I'm afraid. Yeah. The reviewers are anonymous in most journals, but sometimes the reviewer does ask the editor to tell the author who they were. And say sometimes you get the stage where the referees, can be asked to become an author on the paper. They asked for so many changes, they made so many really good suggestions that the author then decides, oh, actually, the referee would be a good author as well, and gets them to join it, sort of thing there. Referees, you shouldn't communicate with the authors, treat them confidential. This is what we said earlier. Try to get the decision, and then most importantly, remember, you want your papers refereeing, so you should be refereeing other people's papers as well there and that there. What makes a good reviewer? People that do the job properly. We want constructive criticism. We don't want people to be nasty. I mean, I had a paper many years ago now where the referee was, he was criticizing me as an individual. I mean, without going into details, the paper was on fish, and a lot of my work before then had been on the benthos. And he said, "Oh, this paper's not very good. It's just written by a benthic person who knows a bit about fish." What they'd missed was the fact that the first author was one of my PhD students who was only working on fish, and also he missed the point, the fact that we had published many papers on fish. But there. So, what makes a good reviewer is all of those sort of things there. You can get rewards for that. You can now get certificates. We're trying to get journals to give us sort of like a frequent flyer program for people who referee. You know, if you referee enough papers, then you get bonus, and that gives you, I know, a open access paper or page charges for publication or whatever. But they're not doing this yet. But eventually they will be there. Now. Okay, so that was it's probably faster than I planned. I keep forgetting how much is in here, but hopefully it's been useful, and you can all get the well, you can get the slides. I can't remember if Gemma recorded it, but Ron's there. So anyway, so I don't know if there was any other questions.
Yeah, we've got one in the chat from Dorota, but she can't put a microphone on right now. So
Okay.
it's really, how can ECRs put themselves forward as reviewers? So if we've got very little publication record, or our expertise is deemed quite minimal because we're the career researchers, how would we go about becoming reviewers of papers?
Yeah,
I
no,
think about the ICES journal having a young editors and reviewers, but is there any other programs like that, or do you have any good advice?
I haven't seen other ones that have got a young reviewers program, but we get I get people, and I encourage all you to do it as well. I get people writing to me and saying, "This is what I'm working on. I'd be very happy to review." And even if you say, I haven't done it before, and I'm really quite inexperienced with it, but and we'll say that's fine, because it won't just be you that's doing it. It'll be going out to experienced people as well. I don't think I'm doing well. No, I haven't done it yet with you, Gemma, because your field doesn't come into my journals. But my other postgrads I will have asked them while they're doing their PhDs to referee papers. And even one, and I know one or two have said to me, but I haven't done it before. So no, that's no problem. No, I'm sure you'll do it as good as you can. And by the way, I'm not just relying on your comments. I'm relying on I've got other people's as well.
That's grand, thank you. I know Amanda asked me to review my first one, and I'm very scared to begin with. Well, how could I judge someone else's work?
Yeah, no, that's it. No, but as I said, you're all now you're all actually probably closer to the literature. You probably got a bit more time to sit and read these papers and go through them thoroughly as well. So postdocs are, let's say, PhD students who will be good at it. Postdocs are usually the best reviewers because they are focusing on one very precise topic, sort of thing.
Yeah, just whilst I'm letting people have a little think and maybe put some questions in the chat, I'll put the hands up. I do have a question regarding interdisciplinary researchers. So in a few of our past meetings, we've been talking about what did we call them? Unusual collaborations, and where multidisciplinary researchers come together to write a paper. So wondering if you had any advice on how to select an appropriate journal when being very interdisciplinary, and how you could, say, tailor your writing to make sure you tick the right boxes, but you're not missing out or compromising your message because you're spanning disciplines.
Yeah, this is it's not only difficult for writing papers, it's difficult for grant applications as well, as we all know. You write a grant application, and if it's supposed to be multidisciplinary, the easiest way of rejecting it is say, you're multidisciplinary, but you haven't got enough of this discipline because you've got too much of the other discipline. And it's the same with journals, sort of thing. So, for example, Estuarine Coastal and Shelf Science, we are more a science, we're not more natural sciences. So if I get something that is spanning the natural and the social sciences, even though, as Gemma knows, that's more what my field is, we probably don't take it. We will say, no, actually, you want ocean and coastal management or one of those things like Science of the Total Environment. That's a good journal for multidisciplinary papers. That it was shortened to STOTEN, but Science of the Total Environment will do those sorts of things there. Whereas many of the others, things like marine policy, if you've got too much natural science in, they use that to say, oh no, we're going to have to reject it. Marine Pollution Bulletin is another one that takes multidisciplinary papers as well, sort of thing there. So there are these ones, but I say all you can do is say, well, what did it say on the title on the journal's webpage? And how do we does that emphasize this multidisciplinary? But you do have to be careful that you're not overemphasizing one or the other. It's the one of the I said about rejecting papers. I get given a list, and the list is sort of accept with minor revisions, accept with major revisions, transfer pre-review, transfer post-review, reject out of scope. There's a whole load of them there anyway. Reject out of scope is it doesn't fit our journal. Transfer pre-review means that it's better suited to another journal. I'm going to transfer it. I'm going to say you can transfer it to another journal, and I'm not wasting our reviewers' time on it. Transfer post review is where, as I said earlier, I had one this morning, and the referee said this would be better going to a wholly crustacean journal. No, it's so specialized. Go there. One of the sets of papers we get that we just can't do anything with are on the microorganisms foraminiferans. And I know if I accept a paper on foraminiferans that nobody's going to read it. There's only about 5 people in the world that work on it, and they're probably all co-authors of the paper anyway, sort of thing. So what do I do with it? And I'll say, no, look, sorry, it is too specialized. Send it to, there's a journal called Micropaleontology. But I've had the authors write back to me saying, oh yeah, but I that's where we always publish, but we want to reach a wider audience, and that's why I've come to you. So then say, in that case, you have to write it for a wider audience there. So there are some good journals on, the multidiscipline now on multidisciplinary ones, quite important things there.
Yeah, I feel like it's definitely broadening as ecosystem-based management evolves. But there's a question from Irene about tips to do with like theory finishing a paper, or from your experiences, if you've got any guidance. I don't know if you want to come on, Irene, and ask the question.
Yeah.
I hope you can hear me. I changed my headphones.
Yeah.
Just my question is like, what do you do when you have a block? Like a fear of finishing a paper, that you have a paper that already has comments and corrections, and it's all like, gray, and you're like, you have to finish and send it, but it's just in standby there, and it's just something more important, and then they just keep adding.
The reason I'm smiling, Irene, is because we all recognise this. And those of you who are doing theses will get into this stage where you don't want to let it go because you think, no, I can do a bit more on it. I can do a bit better on it, so that you don't let it go. And we all get that, and we all have papers that take a while. I said I'm working on a paper at the moment, and I said the other day to someone, I said, I don't know what the most versions we've had of a paper, because we always write a paper and put numbers of the version in the title, and I had one which was version 24 things there, and we were just going backwards and forwards, and you get to the stage, what you have to do is get to the stage of saying it is good enough to be refereed on that, because remember, if you make it perfect, if you wait until it's perfect, then well, what do the referees will say? Oh, it's perfect, that's fine. Or no, they never say it's perfect. They'll find something. You want it to be good enough to be refereeable, if that's a word. It has to be refereed, but not too bad that it gets rejected. You need it to go to the next stage, sort of thing there. So we'll, none of us like letting go. One of the other fears is that none of us like a blank screen either. When you start writing a paper, the worst thing is you're staring at a blank screen, or you're staring at a blank piece of paper. How do I get started? And what many of us do, I just write the stuff down. I just have a brain dump on it and that. And General have heard me say this before. Get your ideas down. It doesn't. There's a paper I'm working on at the moment. We had a meeting yesterday. We're trying to write a paper by committee on Google Docs. So we have a meeting, we all go away and write a paragraph, and then we just put it in there. And the worst thing is sitting there with a blank screen. So just have a brain dump, put the ideas down, and then start working on those. But I'm sure the paper your thing, your case there, I bet it's getting to the stage where either you're confused because you've got so many comments. One supervisor says this and another supervisor says that. Well, then remember, you're the first author and it's your work, so you put it down there and that. You can't reconcile those, but just get the final version, get it refereed, because the referee will come back there. But I say I was smiling because letting go. I've known people who haven't submitted their theses because they've said, I don't think it's ever good enough. And you say, well, what are you working for? Are you waiting for something perfect? It'll never be perfect. Just get rid of it. So all I can do is encourage you to, just let go. Do all the corrections to it. Do all of those, the corrections in the margin. When I'm working with people on papers, what I sometimes say to them is, don't put comments in the margin. If you've got it in track changes, you put comments in the margin. I'll say to them, don't put comments in the margin, because someone has got to take that and put it in text in the paper. If you think it's an important comment and it needs to be added, put it in. We can soon adjust it or get rid of it or whatever. And then I'll say, and by the way, I'm going to have the final say on what's going to go in the paper. But or the first author does that. I wouldn't dare tell Gemma she couldn't write something in a paper. Well, I might do. Yeah. That's
grand. Thank you.
Just to, I had a compliment for that question. Like, how old can a paper get? Like, because then, the papers pile up. Then you, like, as a student, you're like, no, my thesis, I did that like 4 years ago. Like, I don't think it's publishable anymore. So, like, how do you assess if it's still something important or not? Or you just go to lower journals?
Well, you could do, but what you do is, if the idea is good, You know, if you think you've got a good idea, it doesn't really matter when the data are done. I mean, in my thesis, I published most parts of it, but there's one chapter I didn't publish, and it was an experimental chapter. It was all done in the aquarium. Now, I occasionally I think, well, actually, I could just I could republish that now. I mean, there's a huge amount of statistics and data in it, and that. It's like a multivariate experiment, huge experiments. And the date when I did it doesn't matter. I mean, the fact that it was, Jesus, 40 years ago. Anyway, when I did the work, doesn't matter because the data are still good. The only problem you have is if you did it in a field situation and somebody says, but that situation doesn't exist now, it's already changed. So if you wrote it as a geographical case study, this is what the area was like, people can say, that's a bit dated now. But even then, no, is it still? Whereas if you write it as there's this fundamental thing that happened, doesn't matter when it happened, and it's quite likely it will happen somewhere else, then no, I don't don't have any regrets. That is, don't keep thinking I should have done something and that. Just do it, or if you're not going to write the paper, just forget about it. Put it in a drawer and forget about it and then that. But no, if it's a good idea, and it's valuable information, then I just get it out. And then the second thing you said, I mean, it was about go down the journals. You know, okay, so it's not making a science paper or a nature paper, but it might make ECSS, or it might make regional studies in marine science that takes these geographical case studies. That's got an impact factor now. I think it's about impact factor 2 or something like that, which means that people are reading the papers in it. Don't head for the Pakistani Journal of Animal Biology or whatever it was. Yeah, I shouldn't give up a journal. That was one that I had a particular problem with, but things there. So, but no, if it's a good idea, get it published. And also, Irene, think, what is the worst that could happen? The worst that could happen to your paper is the journal rejects it. Okay, but at least you tried. That. And I've got one paper that we submitted it, and the referee said there was one bit of the analysis that they didn't like, and at the time I just couldn't be bothered reanalyzing the data, and it never got published. And it's a good idea, but it never got published. But what the hell? But anyway, no, just go for it. Let's say it's.
Thanks, Mike. We're a little bit over time, but there is just one last question from Wendy, which I'll be able to pass on the answer. And it's if we would expect our supervisors to guide us toward those, most appropriate journals.
Yeah.
So if someone else, I feel like I've got the gold star supervisory team, but if someone else was to just have a relationship with their supervisor, is that something that they should expect of them? Is that reasonable?
Yeah, the supervisor, who I guess will be one of your co-authors anyway, the supervisor should be in the best position to advise you. If I mean, I was examining a PhD a couple of weeks ago in London, and the student was working on a field which was outside the supervisor's field. It was the supervisor was moving field, so the student actually was better placed than the others, and so the student was in a better position to choose the journal. But I say the easiest thing is the supervisor should advise you, but where are the papers coming from that you're using? They should give you the they should give you the best idea. sort of thing. But as I said about going for the top third of journals or top quarter of journals, start with the best ones and work your way down. So you're working your way down the list, and you're saying these are the criteria of the journals. Where do these meet, sort of thing. And it was and yeah, you'll find it. Go for good journals. The problem now is that, and you are all getting them as well, we all get these letters every day from journals we've never heard of that say yeah, if you send us your paper by next week, we'll publish it in this one there. And so, well, I've never heard of it. I wouldn't publish in a journal that I've never heard of and that I don't know anyone else publishing. It's a bit of a problem, those of us working in the European projects at the moment, because we've all been told now that excuse me, that the eligible costs, that open access fees are only eligible for true open access journals. So things like Estuarine Coastal Shelf Science, Marine Policy, Marine Pollution Bulletin, MEPS, Marine Ecology Progress Series, these are all hybrid journals. And so in theory, the paying the open access fees for those is not eligible. It's not an eligible cost. And we don't understand this because the logic is ridiculous. If it's open access, it doesn't really matter where you pay for it. But by the same token, I think in all these projects, we've only put, the ones that you're involved in, we've only been able to put a couple of thousand euros in for open access publishing. Well, that might be one paper. So you have to publish in all the other papers as well. So anyway, yeah, that was good.
Awesome, thank you. So just a quick wrap up. I'll do a shameless plug. We have our monthly meetings for the ECR community. This seminar session was opened up to those outside the European projects. So other initiatives such as the ASDE Summer School, which I believe next year's on ECR skills and tools, but more information will be shared through our LinkedIn, through our Twitter account. For those members who are part of a European project looking at marine ecosystem-based management, you can see quite a few of the logos on the pictures, but if you are part of a project, please reach out because we're looking to expand this community, have some good inter-project collaborations. So that's my shameless plug for this evening. And thank you ever so much, Mike, for your time. We really enjoyed this session.
Okay, thanks a lot. Okay, bye everyone.
Bye, have a good evening.
And you, bye then.
Bye, thank you.
Bye.